thanks everybody for coming today. This is the ninth community meeting of 2020. We've got a pretty interesting schedule today. I'm quite excited about some of the stuff we'll be talking about. Those of you who have been to the meeting before know to just add yourself to documents so we know who comes to the meetings. But if not, please add yourself and just say where you're from. We're going to be talking about Argo events and Argo workflows in this meeting. Argo Events is a cloud-native system for scheduling events. Typically, you'll use it if you want to trigger something in your system. And that thing might be a workflow. So Argo workflows and Argo events are often used together when we use them ourselves. We're going to be talking a little about Argo events going GA, going 1.0, and Derek and Vipav will be talking about that first. We'll also be looking at the Argo workflows roadmap, just to show you what's coming up in the Argo workflows universe. And then we've got two presentations, demonstrations. Firstly from Thomas, who'll be showing us how to build Kubernetes using Kubernetes. And then Terry will be showing us Couler, which is an interface for constructing and managing workflows. And then we have the opportunity for any other business, any questions you want to ask at the end of the workshop. Now, if you do want to ask questions during the workshop, you've got a couple of options. You can ask out loud if it's a short or quick question, or you can ask in the chat room and we'll read your question out. Finally, we will be able to answer any questions you have on Slack afterwards if they're particularly long or involved. We are recording this, so we'll be sharing that recording on YouTube later on if you want to share that or come back and revisit any particular aspects of it. Okay, so our first thing is going to be Argo events. That'll be presented by Vipav and Derek. Vipav is one of the original, if not the original, code contributor for Argo events, and Derek is, a key contributor, been working on Argo events 1.0. Are you ready?
Yes, thanks, Alex.
Good. Okay, take it away.
Yep. Let me share my screen. All right. Can you see my screen? I guess yes. All right. Hello, everybody. My name is Derek. I work for Intuit. I'm a software engineer, mainly worked on Argo Events project. Today, we're going to introduce the new things in new Argo Events. Some of you might still remember back in May, I made a presentation about the proposals to enhance Argo Events. And today, I'm excited to announce that all those proposals has been implemented, and we have successfully pushed Argo Events to version 1.0. And let's see what's new in the new Argo Events. So we have two parts today. First part is I'm going to introduce the architecture change in Argo Events. The main purpose for the change is to make the system more reliable, easy to use, and more secure. And then I will hand over to Vipav to introduce the features enhancement in the new version. Architecture. One of the biggest things we introduced in Argo Events is a new concept named Event Bus. Event Bus is a namespace CRD. It represents a PubSub service sitting between the event source, the events detector, which is the event source today, and the events consumer in the system, which is sensor. Right now, it's backed up by not streaming. So the simple example I give here to create event bus is you give a name default, and then you give a keyword native, and then that means we're gonna create a native not streaming service for you in your namespace. And that not streaming service will be used as a message transmission center in your system. And all the events or the message detected in the event source will be sent to this event bus, and then the sensor will listen to the event bus to read the message in events and trigger downstream actions. So that's one of the biggest change in the new version, in new Argo events, just event bus. And also we are open to support other technologies like Kafka in the future. Right now it's backed by not streaming. Another big change in the new Argo events, like we simplified the specs to make the whole service easy to use. Among those, one of the biggest things is we merged gateway CRD to event source. And I also give the migration path here if you are still using the old version of Argo events, which is less than 0.17. If you want to migrate to the new version, it's, for example, we 1.0, what you need to do is to move if you have anything under the gateway spec under spec.template, and just move it to event source. And same thing for the spec.service. That's I think that's a straightforward for the migration. It's not a big deal, quite easy to do that. And so we can do a comparison about the new spec and the old spec. On the left side is that's an example we used to do to create a calendar type of event source. What you need to do is like you create an event source name with type calendar. You give the spec there, and you also need to give a gateway object on the bottom, which I marked as red. And that's the old spec. Right now, in the new Argo events, you only need to give the event source spec like on the right. I think it's more than 50% simplification for the event source. We also simplified something on the sensor spec. So left side is old spec, right side is new. And then there's one thing need to be changed in the sensor spec is a dependency, because the gateway spec is going away, and then there's no gateway name anymore. So for this, even for dependency, you have to change the gateway name to event source name. I think that's the only required change for sensor spec to migrate from the old version to new version. And also, originally you need to give a subscription, like issue on the left. And then in the new version, there's no need to do that because we're using the event bus. The sensor will by default to look for the default name, the event bus. And there's no need for you to do that kind of thing. The other important change in the new architecture is we make the whole system more secure. We re-implemented all the controllers and services in the system. Originally, you need to specify a service count, a privilege service count basically, to create an event source or gateway and sensor in whatever event source or whatever action you want to trigger in the sensor. And right now, for event source, we have like more than 20 type of event source. There's only one event source that's needed to specify privileged service count, which is event source to watch the Kubernetes resource change. And that's for sure. You need to have a privileged service account to do that. Otherwise, you're not able to watch those kind of changes. And for sensors, you only that's similar here. If you want to trigger some action like to create a Kubernetes type of event source, a Kubernetes event source, sorry, and or to trigger some Argo workflows, and you need to give a privileged service count, and you only need to give the give the RBAC settings which relate to the. For example, you want to create an Argo workflow, you only need to give the create action, a create privilege to Argo workflow. That's a thing you needed. And I think this will make the whole system more secure and make it easy to use for you, because you don't need to configure those RBAC settings for event source and set for most of them. And this is the new high-level architecture. We have 3 CRDs, we have 3 controllers, event source, event bus, and sensor. And the event bus controller is used to manage the event bus object. And then the event source deployment or write the detected events to the event bus, and the sensor read the message there. And it's quite straightforward. I hope you like the new architecture. And next, I'm going to hand over to Webub to introduce the features and enhancements in the new version.
Thanks, Derek. I'm going to share my screen. All right. Hope everybody can see it. So I'm just going to go over some of the features and enhancements that we introduced in 1.0. So one of the, I think the main highlights of 1.0 is that we simplified the use of circuits. So you may remember from the like the previous versions of Argo Events, we introduced like circuits and switch to better manage the dependencies. Like before 1.0, we used to have this concept of dependency groups where you basically group dependencies and then you apply circuits, and in the triggers you have switch based on the circuit and switch combination. You get to decide which particular triggers are executed when certain dependencies are met. And that was, I mean, you had to like configure both circuits and switch to execute these triggers, and it was a bit complicated. And it was sort of like also confusing to wrap your head around, is like what's going on. You have to like define groups, circuits, and switch to basically manage your triggers. So we sort of like simplified that. And then we introduced this new field called conditions under the trigger templates. So what this condition basically does, it simplifies the circuit and switch into one field. So you don't have to define circuit at top level and then apply switch at a trigger level. You can just define condition that takes a Boolean logic itself, like a Boolean circuit. So over here, for example, I can just say conditions is dep02. That means that whenever I get a event for dependency named dep02, Argo event should basically trigger this particular template. Just make HTTP call. That's this trigger. So you can basically make this more complex. You can say that there can be another template, so, and the condition can be like dep01 and under dep02. So basically, this particular trigger is waiting for both dep01 and dep02. Both of these dependencies to happen, and then only it's gonna get executed. So you can see like we basically simplified the circuit switch into just one simple conditions. So that's one of the highlights of 1.0. Going to the next slide. And then we introduced a bunch of other features as well, especially introduced Pulsar event source as, so basically like, this is a new event source that's added to the existing list of event sources. Also, we sort of like, because we decommissioned Gateway, we also got rid of the client server architecture within Gateway. So now the event source itself, that's managed by event source controller. So the event source pod, when it gets spun, it's just one binary. So all the event source are just part of that particular binary. So it's also very easy for a new developer to write an event source and just plug it into existing code base. So that's just another, I would say, an extra enhancement to the existing sort of like features of event sources. And then we enhanced filters, especially the data filter. We added operations like you can now basically perform operation like is equal to, less than, greater than, not equal to on the data filters. So it just gives you more power to filter your event payload based on the fields. Like you can apply these operations in the fields in the event payload, and then so that's what the enhanced filters are all about. Also, each event, whenever you configure your event source, we now basically expose this functionality where user can like sort of define a static metadata. So what I mean by static metadata is, so whenever, let's say you configure event source and you provide some static key values in the event source. So whenever an actual event occurs, this sort of like key value pairs are injected into the event payload. So you get the actual event, but then with that, you get this extra information that was configured at the event source creation time. So it's just, and sort of like, there are certain cases when you just want an extra information wherever an event happens, and I think this sort of like helps in that situation. And then there has been sort of times where people in the community, they asked for like authentication for webhook type event sources, and we usually advocate that basically the users should take care of authentication, may it be the API gateway or specific enterprise solution, whatever it can be. But there are certain cases when you're just sort of like researching certain things and you just need a simple authentication for your webhook event sources. So this is just a simple sort of like auth feature where what we do is we store a secret that basically contains your auth key. And whenever you make a request to, or whenever any other external party or whatever event source sends a particular payload to the webhook event source, we just make that simple check whether the payload or the request has those particular headers. And if so, the request goes through. If not, you get an error. So that's just a simple auth check, but I think it's very useful for like just like sort of like testing out the event sources and making sure that it works. Then we also introduce health check endpoints for, again, webhook event sources, so that you can now basically query these health points, health checkpoints, basically, to see if the event source pods are up or not. Also, before 1.0, when we had gateway, this wasn't possible, where you can where you get to club like multiple different like types of gateway into one gateway. So before 1.0, when we had gateway, a gateway, I mean, the strategy was when you deploy a gateway, it could be of just one type. For example, if you deploy a webhook gateway, it can't understand S3 event source. So webhook gateway can only understand webhook event source. So that was the case before 1.0. But with 1.0, what we did was we sort of like switched from that particular sort of like strategy, and then we introduced this new event source deployment strategy where not only you can basically run event source of that particular type, be it webhook, S3, SNS, SQS, but then you can club event sources of different types into one deployment. And then there are strategies that are documented online. Then you can go and refer to those strategies, which particular event source you can club into one deployment. And so those are the event source deployment strategies. And I think it has a lot of value, because if you are so if you have a use case where you just want to run a bunch of like event sources and you don't want to like essentially like deploy tens or like multiple pods, basically, you can just use this deployment strategy to sort of like club all these event sources into one pod and just deploy it in the cluster. And then, as Derek mentioned, we made the entire platform, the framework, secure by removing unnecessary service account usage in both sensor and in event source. So these are I'm just highlighting some of the features that are introduced in 1.0. There are other features as well. There has been a lot of bug fixes as well, but these are some of the, I think, more important highlights. And I think that covers it all. And we can open up for Q&A. Alex, back to you.
We have a couple of comments in the chat from S. Lucas. He says, thank you for being super responsive in the Argo Events Slack. And then there's a hand clapping symbol. And from Sean, health check endpoint, yay, thank you for that. So some appreciation out there. Okay, onwards. Let me get the right window here. So thank you very much, Derek and Vipad, for giving us an overview of Argo Events. I think it's really good to see such great progress, especially the features around security and usability. We know that our users will really appreciate that. We've just been in the process of kind of formalizing a more longer-term roadmap for Argo workflows, and I'm just going to give you guys a bit of a preview of the kind of things we're planning on doing in the future, with maybe a bit of an explanation about why that is. You can find the roadmap on our documentation website. and you can just search for roadmap in there as well. First item is kind of improvement in the SDKs. If you've been involved in the Argo SDK channel, you'll see that we've actually started releasing a newly updated version of the Java SDK for workflows. There's also a Java SDK for Argo Events that's just newly released, and also the Python SDK is being updated as we speak. You probably don't know this, but there are about 5 different ways to trigger a workflow in the system, and we want to continue to provide more support for that. So recently we've added the feature to trigger one workflow from another, as well as the ability to trigger workflow from webhook, such as GitHub or GitLab. Scroll down to controller enhancements. So we have a group of features coming under a controller enhancements. Memoization is a new feature whose goal is to make it easier to run workflows quicker. Basically allows you to save the results of the steps of a particular workflow and then reuse those results. That allows you to have workflows that have similar steps in it and don't repeat the work. We've also just recently added support for semaphores, and we're in the process of adding support for musexes, which allows you to lock one or more workflows accessing a shared resource. So if you have a particular database you don't want people to access concurrently, you can use that. We are hoping to do task level priorities and maybe the ability to more fine tune just generally the execution of nodes within workflows and across workflows. So task level priorities will allow you to choose which particular tasks execute first. We're hoping to do some enhancements around artifact management, which is obviously a key feature in Argo workflows. So improved performance, improved support for Argo artifact repository reference, and things like automatically creating buckets around artifacts as well. This is actually quite a large piece of work because of the number of different places you can store artifacts. We are going to introduce some metrics and reporting features. This is not really something we have today at all. And so the ability to predict how long a workflow will take or nodes within a workflow, that'll be coming in the future, as well as the ability to look at historical execution of workflows to see how long they took in the past and how much resources that they were consuming. We're going to finish out the RBAC features. That's the #1. Actually, it's not now. This is actually incorrect. It's actually the #2 community voted feature. #1 now being the training session. Allow you to support users with different access permissions through the user interface. Scalability, reliability, and performance is a key feature. We did a lot of work on this earlier this year to improve the support for kind of running large numbers of workflows and kind of very large workflows. And so we've been doing some things like failure mode testing and stress testing, and we've come up with a number of features that we want to implement around improving our ability to lay out large workflow graphs, which will be coming in version 2.12. And we're also going to be introducing some further performance improvements in, I correct myself, that graph layout's coming in 2.11, not 2.12, which should drop next week, I think. And in 2.12, we're going to have a number of other features around things like what happens if a pod or a node is deleted, how to deal with that, how to deal with kind of very large numbers of concurrent workflows. And these will be coming up in the future. We're looking to improve Argo Events integration. This hasn't been fully defined yet, and there are quite a few potential things we might be doing on the cards around user interface improvements, and more specifically making it just really easier to understand why did my workflow start, who kicked off my workflow and why did that happen. A few of you are aware that we have a workflow template catalog now, which is a place to share templates for common workflows tasks, such as building Docker images or compiling applications. And we're going to continue to build out the number of templates in that. And the final item on the roadmap is more use case specific enhancements. So the kind of things that people are using for workflows today, looking to kind of make sure we have the specific features that are needed for that. So obviously people are using this Argo workflows, things like ETL, data pipeline processing, batch processing, machine learning, AI ops as well, and also CI and CD. And we're actually looking for more people to come up with the designs for that, more people to come up with contributions around what kind of features they need to be able to do that. Anybody want to ask any questions about the roadmap before we continue on to our next presentation?
So I can see a question from Leon on the chat. He's asking, are there plans to create an Argo Events UI? He's saying that it would probably be nice to see which event sources are triggered without having to do kubectl logs.
So that's definitely something we've been discussing for some time now. One of the challenges around that is that it's actually quite a large piece of work to do that, and so we're still potential future improvement to Argo workflows was actually to make the user interface a separate application, a separate deployment that has a couple of other features around potentially multi-cluster support and also Argo Events support out of the box, along with other more general features. But we're not really sure what direction we want to go in with that at the moment. There's a multi-cluster and obviously multi-tenancy, because obviously multi-cluster implies multi-tenancy.
Another question from David. Are there any plans to have support for pre-warm pods in the flow to eliminate slow start?
Nobody has requested that enhancement. So my thought would be that you should probably raise an issue in GitHub and present your use case.
Question from Zach. Any work to be done on workflow throughput, as in the number of jobs submitted? But this is mainly a Kubernetes issue with the K8s API.
Yeah, I mean, with all these performance improvements, you invariably just move the bottleneck to a different place in it. So we're definitely looking at improvements that allow us to run more concurrent workflows and kind of larger workflows. And the goal is to kind of be able to run, you know, thousands of workflows concurrently in each workflow with your thousands of nodes. That's the ultimate goal. But yes, so you move the bottleneck around. Sometimes the bottleneck simply moves to your, you know, the Kubernetes API.
Is there any procedure for showing interest in specific use case enhancements? I can actually answer this one. The best way to show your interest in a specific feature or bug is to upvote the issue on GitHub. We commonly sort by most upvoted, just to see what the community is interested in. Another question from Christina. That is a great roadmap. Is there anywhere we can check what improvement is targeted for which release?
So improvements are typically targeted for a specific milestone. I would look in the milestone to see if it actually hits that milestone, because not all improvements. Some improvements actually make up earlier milestones, but also commonly improvements miss milestones. So you need to obviously just check in the milestones tab in GitHub for that. Okay, any more questions?
That seems to be all.
Okay, thank you, Simon, for helping out. Okay, let's go back to the agenda. So next up is Thomas he's from SAP Concur, and he's going to be talking about building Kubernetes using Kubernetes. Thomas, are you ready?
Hi, yes. I'm gonna share my screen. So you can see my screen, you can hear me. Perfect. Okay, let's get started. I'm gonna hide these floating controls. Can you see the presentation now? Black screen.
Yes, we can.
Yes, perfect. Okay, hi. So my name is Tomáš Valášek, and I'll be talking about building Kubernetes using Kubernetes today, or in other words, using Argo to build Kubernetes. So I work in a container ecosystem team at SAP Concur, and our team is responsible for building and maintaining hundreds of Kubernetes clusters for our internal developers. So SAP Concur uses a Kubernetes offering from AWS, specifically the AWS EKS. And so to build EKS cluster is as simple as EKS control create cluster. This is nice and convenient way how to quickly bring the cluster up and poke around. However, to build production-ready Kubernetes cluster, you need more than this. So our team uses 4 build stages to create production-ready Kubernetes cluster. We start with pre-flight tests, which so we target against the AWS infrastructure before we start actual EKS build. After that passes, we go ahead and we start building the EKS control plane, and we attach custom worker node group. So after that, this step is completed, we have a bare-bone EKS cluster ready. We want to give it a little bit of frosting, and so we install some add-ons. The list varies and can be huge, but a few out of many that we install: autoscaler, ingress, or some logging integration. As I said, the list can be long. After add-ons are installed and before we hand over the clusters to our clients, to our developers, we want to make sure that the cluster is validated. We run a few end-to-end tests against the cluster. We run functional tests against the add-ons, so we make sure they function as we expect. So each of these stages requires a different set of tools and different techniques that we use. And so we in the team, we were looking for one tool that would glue all this together. And guess what we found? Yes, we found Argo, specifically Argo Events and Argo Workflows that we use. So in the next slide, next slide, I'll show you a build of a production-ready Kubernetes cluster using Argo Workflows. I'm gonna skip Argo Events here, but Argo Events plays as important role here in the build process as Argo Workflows because everything is API driven. So let's go ahead and jump into Argo Workflow screen. So what you see here is one Argo cluster that's running Argo Events and Argo Workflows. And from this one cluster, we built hundreds of other EKS clusters. I need to add production-ready EKS clusters. So is it big enough, guys? Or do you want a little bit larger? Is that okay?
Yeah, it looks good to me.
Okay, so here we have one build from today's morning. And so what you see here is the 4 build stages. This is a view, this is a very zoom out view, but I'll zoom in a little bit. So what you see here is we start with a pre-flight test. Those pre-flight tests run in parallel, so it's very fast. As you see, we really love that retries come for free for us. If a test fails, we can repeat it again. The middle part is actual EKS build control plane and the worker node groups. This part here installs the add-ons, and we've selected only some add-ons to be installed while others are skipped. Again, what you see here is parallelism, dependencies, and also some conditionals. And the last step is, again, the cluster validation. And what you see here again is the lovely retry feature. When the test fails, we keep repeating 10 times until we mark it failed. But as you see, our build here succeeded. In similar fashion, we delete cluster. That workflow is much simpler, and we have few other workflows that I'll mention on the end of the presentation. So back to the slides, and I'll be speaking about some Argo features that we use here. So I'll start with Argo Events and the sensor parameters. So this is something I really, really like, and that is that you can submit parameters from sensor and replace workflow template spec. So basically what you create a template of workflow templates, which is it's a lovely feature that I like very much. And so as I mentioned earlier, we use workflow templates. All the 4 build stages that you saw are in their own workflow template, and we have a bunch more. This allows us to combine them together or even run them completely independently from a cluster build. That means I can run a pre-flight test completely independently from a cluster build. I can install add-ons against targeted EKS cluster without building a cluster from scratch. So this is very, very powerful, and everything is API driven thanks to Argo Events. From other features that we use, it is the retries, parallelism, dependencies, conditionals, and many more. Before my last slide, I need to mention that a few months ago, Alex ran a pool, and we represent the minority of Argo users that use Argo to build infrastructure. And it is a perfect fit for our use case, or perfect fit for a building infrastructure in general. And in my last slide, I want to express my gratitude to Argo community and to container ecosystem team at SAP Concur. Thank you. That was all. And if you have any questions, please feel free to ask.
So there is a question from, I think it's Daniel, if I remember correctly. Sorry if the D stands for something else. How do you manage the life cycle of the cluster in between creation and deletion? Let's say managing the configuration or versions of various add-ons that you have. How do you upgrade the clusters and node groups, etc.?
Yes, this is something that is work in progress. A very good question, yes. Work in progress, this will be, in my opinion, pretty difficult workflow to create, but with the conditionals and with all the Argo workflows features and with Argo events, I'm sure this is doable too. We don't have it yet. Yes, that is the short answer.
Does anybody else have any other questions before we continue?
Just curious, what version of Argo Events you're running?
Sorry, what?
What is the version of Argo Events you're running?
Oh, yes. If I remember correctly, it is still 0.15, maybe 0.16.
I see.
Okay, Thomas, thank you very much for that presentation.
May I ask, because I tried to type, but it's not fast enough. We used Argo in a similar use case, but for orchestrating network functions, network services. And one thing that we came to realize was like, it's a workflow, right? So it starts and ends, but natively in Kubernetes, you usually use operator, right? So you never actually deploy anything. It's always in the constant state of failing. So you kind of do not assume that you already succeeded in the previous step if you really need to orchestrate something. So did you have some insights into this? It's like we had to do sort of a never-ending workflow. It's finished, you just start again, and finished, you start again, and so on. Because you constantly want to make sure that what you already deployed is still working.
I'm not entirely sure I understand the question here, but we do use some watching mechanisms. So we periodically check for status before the next step can start.
Yeah, well, let's say you are in step 17 and then your step 5th was successful, right? But what it really means that step 5th, you set up some component of your architecture, right? And then you are now in step 17. Now that component that you set up in step 5th is now down, but you are in a different place in your workflow, right? So how would you react to that? Would you restart it from the topological order from where you are right now? Would you restart the whole workflow?
Yes.
Something else?
Yeah, we didn't have this situation, but in case of failure, I'm planning on basically deleting the entire cluster or in any stage where it fails and creates a new cluster.
Okay, thank you. So you just tear it down and then you start a new, okay.
Yeah, I like to start always on a green field rather than fixing. That is almost 2 decades working in operations, what I've learned.
Okay, thank you.
Any more questions? Okay, Thomas, thank you very much for that presentation. Will you be able to share the slides with us so we could put it into the documents?
Yes, absolutely.
Brilliant. Okay. Okay, so next up we've got Terry. Terry will be talking about Couler. You may recognize Terry because he's been an active open source contributor in not just Argo, but also in projects like TensorFlow and Kubeflow. And he's going to give us a presentation on Couler. Terry, take it away.
Thanks, Alex, for the introduction. Can you guys hear me? Okay. So, hi, let me share my slides. Okay. So, hi, everyone. This is Yuan from Ant Group. You can also call me Terry, as that's part of my GitHub ID. And today I'm going to introduce Couler and also talk briefly about its motivation and the project status, next steps, and so on. There are many solutions exist nowadays for constructing workflows and managing them. For example, Apache Airflow. Here's an example of creating a DAG using Apache Airflow. And here's an example using Kubeflow pipelines, creating a flip coin workflow. And here's another example from Argo Python DSL. That's our Argo community maintained project. So however, their programming experience varies and they have different level of abstractions that are often obscure and complex. For example, in particular for data scientists or analysts, they may not be familiar with decorators or even worst case object-oriented programming. So things like decorators here and classes and subclasses, even like with syntax are pretty hard for them to use. So here comes Couler. Couler is a unified, Couler aims to provide a unified interface for constructing and managing workflows on different workflow engines. As a POC, we open sourced our first version with the support for Argo workflows. Here are some core APIs of Couler. For example, here, basic operations, you can define a step. It's similar to Argo workflows. You can run scripts or Python function or a container or even custom Kubernetes resources. And there's functions for defining control flows, such as map, when, and while loop. And then functions for defining DAG, in different ways. We will show some examples later. And utility functions for configuring and submitting a workflow and get status and so on. Keep in mind that these APIs are still subject to change because we are still discussing with the community to see what's the best approach in order to support multiple workflow engines. Why would you use Couler then? First of all, it's using Couler, you can use Python to construct your workflow. You can define your workflow programmatically, and that will be translated to Argo workflows YAML specification. And we are also working with Argo community to reuse the Argo Python client for schema validation and so on. And it's simple because it provides a unified interface, and you can use imperative and functional programming style to define the workflows. And it's extensible to support various workflow engines. This is still a work in progress as we are actively working with other communities and organizations. Last but not least, we want to provide a collection of reusable steps for common tasks, for example, distributed training of machine learning models. Here's an example using Couler to for the coin flip example. So here you can define a small Python function and then a function that runs to flip the coin based on heads and tails. And then these conditionals are specified here to call a particular function and start the containers, individual containers, depending on the result of a previous step. So this is, you guys are probably very familiar with this already. And the second example is to construct a DAG using Couler APIs. So on the left hand, you can see 4 functions that defines 4 different jobs, A, B, C, D. And then you can use Couler.DAG to chain them together. This is one of the options. And the other option is to use set dependencies to set them more explicitly. The first one is a list of jobs here. And here you can also define like a diamond DAG shaped DAG using the same API. So the reusable steps that I mentioned earlier, just want to give some examples. For example, Kubeflow operators for distributed machine learning jobs, as well as integration with third-party data sources and storage options, especially the data sources and storage options that we use very heavily internally. And we are working actively with other communities to make this collection bigger as well. Just to want to share some the project status. So we developed Couler and used it very heavily at Ant Group with the initial support for Argo workflows, and it's open sourced at this link. And next steps would be we are working closely with the SDK maintainer, Argo SDK maintainers, for better integration with the existing Argo Python client. Also collaborate with other open source communities and organizations on additional backends and reusable steps and so on. And there are different ways to reach out. For example, we have a dedicated Slack workspace if you want to discuss more specifically about Couler, and the link can be found in the repos README. And also we can discuss on Argo Slack workspace as well. And we do have a Twitter account, which I created it yesterday because I realized that the GitHub organization can include a link to Twitter. So I thought that would be a good opportunity to share important updates and announcements. So that would be it. Thanks everyone. And I look forward to collaborate with the community. And please do reach out to us if you have any feedback and questions and issues. Thanks.
May I ask a quick question, please?
Yep. Go ahead.
That's extremely cool. First, I really like it, but I wonder about the motivation, right? You have this Python for Kubeflow pipelines, right? So you have this DSL for Kubeflow pipelines, but this seems to be at a higher granularity than the pipeline. It's like steps. It's more granular. So what's your motivation here? Because it's look pretty close, but it's not quite the same. So if you can explain a bit.
Yeah, definitely. So we tried, at least in my current company, as well as a couple of other companies we are collaborating with, we realized that Kubeflow pipelines is really complex to use and very have very heavy dependencies and so on. And our data science team do not want to spend a lot of time learning a new DSL using complex Python syntax. So that's our first motivation. And the second motivation would be for different use cases, we would love to benchmark different workflow engines. So by providing a unified interface, it's easier to migrate, say, from Apache Airflow to Argo workflows. That's one of our motivations as well. Does that answer your question?
Yeah, it does. Thank you.
Okay, cool. Yeah, feel free to always reach out if you have questions after the call. Yeah.
We probably will. Thank you.
Thanks.
Any more questions?
I had one question. This is Makalika. Hey, Jan, since you're migrating from Apache Airflow to Kubeflow pipelines or Argo workflow, will you be able to contribute also, like Airflow has some specific tasks for connecting to different data sources, etc. And we are really looking for some of these use case specific contribution. Will you be able to contribute some of those once you have time? And
yeah, definitely we can continue the discussion offline. It will depend on our team's resources and so on, priorities and so on. But
sure.
Personally, I'd definitely be interested. Thanks for sharing.
Sure.
Okay, thank you very much for that presentation. So that's the last presentation for today. So all we really have left, which you may or may not be pleased about, is just any other business. I just want to chat about two things very, very briefly, and then I'll open it to the floor. So we're looking to try and move more questions onto Stack Overflow from Slack, because unfortunately we don't necessarily have quite the amount of bandwidth necessary to answer all the questions that come in from Slack into the future. A couple of people have asked how to contribute. A week ago, I think, Alex M ran as part of the Thursday meeting, which name I forget, he talked about how to contribute to Argo CD. We actually also had done a workshop for Argo workflows back in April this year. I've just added the comments there for people who are interested in finding more about that. Okay, open to the floor. Is there any topics that people would like to discuss? Okay, It sounds like that's a no. Okay. Well, thank you all very much for coming today. If you do have any more questions or you want to talk about anything else, do come and find us in Slack and we can answer them there. Have a nice day.
Bye.
Thank you, guys.
Bye-bye.